This is Geometry, Unit 2, Lesson 9 on simple angle theorems. A theorem is a statement that has been proven using definitions, postulates, and/or previously proven theorems. Basically, it's a statement that's been made that is used so much that it's proved to become a theorem. So you don't have to reprove it every time. Once a theorem has been proved, it can be used as a reason in proofs. Therefore, it's imperative to memorize these theorems. Now, our first theorem we actually proved on the homework previously. The theorem is all right angles are congruent. Now, for example, if we're given angle A and angle B are right angles, we know the measure of angle A is 90 and the measure of angle B is 90. So what can we conclude? That they're equal in measure, so they must be congruent. So instead of having to go through the proof every single time if A and B are right angles, we can automatically say, using all right angles are congruent, that angle A is congruent to angle B. That statement can be made because we have the previously proven theorem that all right angles are congruent. Now the same thing can be said about straight angles. We can also say that all straight angles are congruent. It's basically proved the same way. Instead of using right angles, though, we would say straight angles. So the measure is 180, so they're equal to each other, so therefore their measures are equal. So basically, if we have two straight angles, we can automatically say that they are congruent. So our first two theorems, all right angles are congruent. If you have two right angles, you can automatically say they're congruent using this theorem. And if you have two straight angles, you can automatically say they're congruent from this theorem. So there's your first two theorems. Let's prove the next theorem. If two adjacent angles form a straight line, they are supplementary. So we want to prove that if we have two adjacent angles, they add up to 180 degrees, and we can automatically say that they're supplementary. So from our given information, we have angle AOC and angle BOC. Angle AOC is here, angle BOC is over here, and they lie on line AOB. So our goal is to prove that AOC and BOC are supplementary so that they have to add up to 180. That's what we have to prove. Now, what do we know that AOC and BOC add up to? Well, looking at our picture here, we have AOC and BOC. Well, doesn't that mean that the measure of AOC plus the measure of angle BOC is equal to the measure of angle AOB? Because doesn't that make a whole is equal to the sum of its parts? This plus this gives you that. Well, that is partition. Whole is equal to the sum of its parts. So angle AOB is actually a straight angle. What do we know about straight angles? Well, a straight angle measures 180 degrees. The measure of angle AOB is equal to 180 degrees because straight angles measure 180 degrees. That is one of our definitions. Now look at this statement and this statement right here. We have AOC plus BOC to get AOB, and we know that AOB is 180. What could we put right here instead of AOB? Well, couldn't we put 180 there? The measure of AOC plus the measure of angle BOC is equal to 180. What did we just do? Well, that's transitive or substitution. We took 180 and plugged it in for AOB. So that's transitive or substitution. Now, we have now proved that angle AOC and angle BOC add up to 180. What happens when two angles add up to 180? Well, they are supplementary. So we can say angle AOC and angle BOC are supplementary, because supplementary angles add up to 180 degrees. So look what we have just proved. Supplementary angles add up to 180 degrees. We have now proved that these two adjacent angles are supplementary. And that's what we wanted to prove. So from now on, whenever you have two adjacent angles that form a straight line, you can automatically say they are supplementary. Now, this also works for complementary, but what kind of an angle would you have to have? If two adjacent angles form a right angle, they are complementary. So we could do this same proof that we just did, but we would, instead of using a straight angle, we would have to use a right angle, and we would prove that they're complementary the same exact way. So if two adjacent angles form a straight line, they're supplementary. If two adjacent angles form a right angle, they are complementary. Let's move on to the next theorem. If two angles are congruent, then their supplements are also congruent. So we have angle 1 is congruent to angle 4, and 2 is supplementary to 1, and 3 is supplementary to 4. And we want to prove that angle 2 and 3 will actually be congruent. So let's see if we can do that. Well, let's see what we know for sure first of all. We want to prove that angle 2 is congruent to angle 3. So what do we know about 2 and 3 right now? Well, we know angle 2 is supplementary to angle 1, and we know angle 3 is supplementary to angle 4 because we are given that. Now, what does supplementary mean? Well, supplementary means that their measures of the angles add up to 180 degrees. And that's the definition of supplementary. So we can say angle 2 plus angle 1 is 180, and the measure of angle 3 plus the measure of angle 4 is equal to 180. And that's because supplementary angles add up to 180 degrees. Okay, so look at this statement we just made right here. Those two angles both equal 180 degrees, so they must equal each other. So I can say the measure of angle 2 plus the measure of angle 1 is equal to the measure of angle 3 plus the measure of angle 4. All right, the reason for that, we just use the transitive property, or substitution if you really want to be picky. It is transitive because they're both equal to 180, so those two statements are equal to each other. All right, now remember, we want to prove that angle 2 is congruent to angle 3. All right, so here's 2, here's 3, and then we have 1 and 4. All right, didn't we say here that angle 1 is congruent to angle 4? Isn't that also given? And that means that their measures are equal. So that's a given statement. If we know that 1 and 4 are equal, what could we do with them from this statement to end up being 2 equals 3? Well, can't we use subtraction? Take this statement, subtract out 1 and 4, and we're left with 2 and 3. So the measure of angle 2 is equal to the measure of angle 3, or angle 2 is congruent to angle 3 using subtraction on statements 2, 3, and 4. I'm taking this statement and subtracting them to get my final statement that angle 2 is congruent to angle 3. So we have just proved if these two angles are congruent, then these two angles are also congruent because they're supplements of the angles that are already congruent. Now, this also works with if you're supplementary to the same angle, they are congruent. If two angles are supplementary to the same angle, they are congruent. So for example, if you had two angles that are both supplementary to a 50-degree angle, they would both have to be 130, right? So they would have to be congruent. So if they're supplements of the same angle, they are congruent. Or if they are supplements of congruent angles, they are congruent. Now, the two previous theorems are still true if the words supplements and supplementary are replaced by complements and complementary. So you could also say if two angles are congruent, their complements are congruent, or if two angles are complementary to the same angle, they are congruent. So we have just gone over our basic theorems. We have one more new theorem to talk about. Our new theorem has to do with vertical angles. So we have a definition here. Vertical angles are non-adjacent angles formed by two intersecting lines. So there's actually, when you intersect lines, you end up with two pairs of vertical angles. Here's your intersecting lines. There's 4 angles numbered here. They are non-adjacent. They're not next to each other. They're formed by intersecting lines. So if I have angle 1, what angle is non-adjacent to angle 1 in those intersecting lines? Well, it would be number 3. So angle 1 and angle 3 is one pair of vertical angles. Those two angles are vertical angles. And angle 2 and angle 4 are also vertical angles, these two right here. All they share in common is the vertex. They don't have anything else in common. They don't have any sides in common. So vertical angles are non-adjacent angles formed by intersecting lines. They're make a V. Here's a V here, here's a V here. All they have in common is their vertex. And the theorem about vertical angles is that vertical angles are congruent. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. You're actually going to prove that theorem on your homework. So, to summarize, here is the summary of the angle theorems that you need to know. Now that you have proved these reasons, or will have proved them on your homework, you can use them as reasons in your proofs. So, all right angles are congruent, all straight angles are congruent. If two adjacent angles form a straight line, they are supplementary. If two adjacent angles form a right angle, they are complementary. If two angles are congruent, their supplements or complements are congruent. And if two angles are supplementary or complementary to the same angle, they're congruent. And vertical angles are congruent. Instead of having to go through and prove all these every single time, if you have the qualities for these, we can use them. All right, now, you will need to know these theorems. There are two proofs that we're going to go over in class tomorrow on the next page, so we are going to use these theorems in the proof so we can see how they do it before we do the homework. So memorize these theorems.